So this is your starting amount. Then the point that they give you is that four months after it stops advertising, so when T is 4, now we are at 80,000. So we are going to get the E part by itself. So I divide by 100,000 and I get 0.8 equals E to the 4K. So rewriting this, natural log of 0.8 equals 4K. K equals natural log of 0.8 over 4. That's your approximately negative 0.055. If you're able to preserve that answer in your calculator, it's going to give you a more exact value. But on my sheet, here's one thing that the AP test sometimes does. One thing that you can do to kind of notate your answer is that if I have some big long string decimal that I need to put somewhere else like this, one thing that they'll do is they'll say, okay, this decimal, let's call it A. In other words, anytime I say A, I mean this big long decimal. So I don't have to keep putting the big long decimal in my work. Does that make sense? So when I go to plug in, instead of K, I'm going to put A to stand for that big long decimal. So Y equals 100,000 times E to the A times, not 2, because it's another 2 months on top of that, so 6. So E to this big decimal times 6, and that's how we get our 71,554. What are our units? Units. Our units are units. Questions on any part of that?
I did 80,000 times K to the 2 and got the same answer.
That's fine. Because you're treating 80,000 as your starting amount and then saying after 2 months, after we hit 80,000, where are we at? That's doing the same thing. It's just treating the variable a little bit different. That's fine. Anything else? Okay. We'll do this one on Friday. So if you want to take a look at it before then take a look at it. But I want to start our next set of notes because that's what we're supposed to be looking at today. The reason these are going to be pretty short is because we have done ideas with this already. Remember how I said that a lot of this semester is working backwards from last semester? Well, it's happening again because we talked about position, velocity, and acceleration and doing derivatives with those. Now, instead of giving you position and asking questions about velocity and acceleration, now I'm going to start to give you things about velocity or acceleration and ask you to work backwards, integrals, to answer questions about position. So, first of all, we're going to go non-calculator into part C, and then we're going to work with the calculator. Like this part C. So, part A first. Determine when the particle is moving to the right, moving to the left, and stopped. The big thing that you need to be able to keep track of in these problems is what things are questions about position, velocity, and acceleration. And so the direction that things are moving is a question about which one? You can't tell movement just by looking at the position. The movement needs velocity to tell me the direction. So determine whether the particle is moving to the right, moving to the left, and stopped. So that's a question about velocity. Luckily, we have velocity sitting right there in front of us. So we don't even have to do any derivatives or antiderivatives. So this will tell us when the particle stopped. Okay, maybe we'll use the calculator on this part. Actually, I don't need it. Because I know 98 is double 49, so I know the answer here is going to be 5. Yes? Sign chart. Because particles moving to the right when velocity is positive, and moving to the left when velocity is negative. Pick a point to the left of 5. That is not to the left of 5. Between 0 and 10, or between 0, anything between 0 and 5. Let's take 1. Pretty easy to plug in 1. 49 minus 9.8. That's positive. And then to the right of 5.
100. Not quite as positive.
Our right end point is 10. So maybe I should put here's 0 and here's 10. So somewhere between 5 and 10. It's going to be negative. So we are stopped at t equals 5. We are moving to the right from 0 to 5, and to the left from 5 to 10. Good so far?
Yeah.
All right. Part B. Find a particle's displacement. So we need to talk about what displacement means versus total distance traveled, which is what part C is asking. All right? I'm going to go this way to show the camera. All right. I want you to tell me how far I moved.
Total distance?
There are two answers to that question. Right?
I'd say about 4 seconds.
Answer number one is you didn't move. Right? Where I started and where I ended are the exact same place. So I didn't really move. I didn't go anywhere. The other answer to that is, well, of course you moved. I watched you go over there and then back here. So you obviously moved. So these are the examples of the two different questions. The first answer of, well, I didn't move at all, is giving the answer for displacement. Displacement just measures where I started versus where I ended. The total distance traveled takes into account the fact any direction that I moved, even if it was a backwards direction, even if I winded up back where I started. So, the displacement should be the position that I ended minus the position that I started. So, subtracting the endpoints of position. Guess what's going to subtract the endpoints of position? It's going to be the integral. Right? Because the integral will take top bound minus the bottom bound. In other words, it'll subtract the endpoints of the position function. So displacement displacement. Antiderivative. We don't need a calculator for this. Plug in 10. Minus, plug in 0. .49 times 10 is 490. 4.9 times 100 is also 490, so this is 0. This is 0. So there's my answer of, well, it didn't move. It moved to the right constant amount from 0 to 5, then moved to the left that same amount from 0 to 5, from 5 to 10. Sorry. From 5 to 10. So it ended the same place that it started. It started at a position of 0, it ended at a position of 0. So it didn't move. Wait, of course it moved. It said we moved to the left and the right. So what we want to do is we want to count that movement to the left as still being a positive motion, because right now it's counting as a negative motion. So the way that we're going to do that, what we had done earlier was we set this up as we had to figure out where it was negative and then subtract to that integral. This is the same idea as like net area versus total area when we did that. So, the easy way that we can do that, counting the negative, making sure that the negative area is counting as positive, is with absolute value bars. That way, the whole function will count as positive the whole time. Yes. dt. Integral of the absolute value of velocity. This is a general formula. Total distance traveled. Is the integral from A to B of the absolute value of velocity. That is total distance traveled. Here's where I want to pull out the calculator. By hand, what we would do is we'd take the integral from 0 to 5, and then we'd subtract off the integral from 5 to 10. And we could definitely do that. It wouldn't be too bad to do by hand. But for time's sake, I'm going to use the calculator because it's going to be helpful for us to know how to use the calculator anyways. So here it comes. I'll come over here. Here it is. What? There we go. All right. The menu is math. Integral is 9. Math 9. That's FNINT. From 0 to 10 of, I want absolute value bars. Math over to number. The first option is absolute value. So math over to number, first option is absolute value. Of the absolute value, and then I'm going to type in the function. (49 minus 9.8 x dx. $245. If velocity is in meters per second, what is this answer in? Meters. I'll go ahead and get you started on this one. We'll finish it. First of all, part A. I want to know when velocity is 0, so I know when the particle has stopped. Zero equals e to the sine of t cosine of t. First off, e to the sine of t. E to a power. When is that 0? It's an answer I keep asking and we keep hesitating on it. So e to the first is 0? It's either the 0, 0. It's e to a negative 0. So e, this part ain't going to be 0 at any point. So this will happen when cosine of t is 0. When is cosine 0? Pi over 2 and 3 pi over 2. And then make your sine chart. Again, this part is always going to be positive. So really, you're just making a sine chart of when cosine is positive and negative. And you don't need my help with that because you're experts on the unit circle now.